investigate the validity of the arguments shown on the right. So the first one we're going to do is A, where it says all triangles are polygons. All polygons are closed figures. And then the conclusion is that all triangles are closed figures. Now what we want to do is we want to make a Euler diagram corresponding to the statement that all triangles are polygons. So there you can see what the Euler diagram looks like to the right. We have polygons that are representing the blue, and therefore we can say that all triangles is in red that are polygons. Now the next statement we want to do now is we want to make another Euler diagram for the second statement saying that all polygons are closed figures. So on top of the Euler diagram for the first statement. So now what we've done is we've added another circle that surrounds that represents closed figures. So now we would say that the Euler diagram that represents the conclusion all triangles are closed figures is now shown to the right. Now in problem solving, the reasoning or argument is said to be valid if the conclusion follows unavoidably from the hypotheses. The law of detachment states that if the statement, if P, then Q is true, and P is true, then Q must be true. The law of denying the consequent states that if P implies Q is true, and Q is not true, then P is not true. Now the chain rule states that if P then Q, and if Q then R are true, then if P then R is true. So therefore we would say that this is the chain rule. So the chain rule follows the following. Now we want to determine if the conclusion is valid. Well, the conclusion is valid because the Euler diagram shows that the conclusion is unavoidably true, and because the statements represent a series of if-then statements to which the chain rule can be applied. Now for part B, if a student is a freshman, then the student takes statistics. Emma is a junior, therefore the conclusion says Emma does not take statistics. Okay, now we first want to make a Euler diagram. Okay, and if a student is a freshman, then the student takes statistics. So here is our Euler diagram to the right. So in blue, the outside circle is statistics. In red, we have a freshman. Okay, now what we want to do is we want to now make diagrams that could represent the statement Emma is a junior on top of the Euler diagram for the first statement. Now let's take a look here. So here's one to the right. And again, notice that a student cannot be a freshman and a junior. So here we have statistics, here we have freshman, and there's the junior. We also have a statistics here, here's a freshman. We can also have a junior that either is taking statistics or is not taking statistics. And we can also have a diagram where it's all around statistics, the freshman's there, and then all the juniors out here are not taking statistics. Now notice that the conclusion Emma does not take statistics is not necessarily true. Therefore, the conclusion is invalid. The conclusion does not follow unavoidably from the hypotheses.